In this question, a student applies a force of 5.13 times 10 to the power of negative 3 newtons to a knife to cut through a stick of butter, as we can see in the image. This applies 3.90 pascals of pressure, just enough to cut through the butter. We're asked to complete the chart by determining the force applied by, the area of, and the pressure applied by the knife. Okay, so we're going to start by filling in our known variables into our table. We've got force, area, and pressure. Now we're told in the question our force is 5.13 times 10 to the power of negative 3 newtons. I can write that a little bit more easily if I change it out of scientific notation. So it's to the power of negative 3. So I'm going to move my decimal point 1, 2, 3. That gets me 0.00513. I'll write that out again here. 0.00513 newtons. That's my force. I can fill that in here. I could also have written this directly in scientific notation in the answer box. We can see here the way we write scientific notation is using an E instead of times 10 to the power of. So this would be the same as writing 5.13 E negative 3 in the answer box. Okay, then for our pressure, we're told in the question the knife applies 3.90 pascals of pressure. So we can fill that in here. Awesome. Lastly, we need to find the area. So let's head to our reference sheet and find an equation for force, area, and pressure. Here we have the definition of pressure equation. Pressure equals force divided by area. So we've got pressure equals force divided by area. We're looking to find the area. Right now, area is on the bottom of our fraction. So I'm going to multiply by area on both sides of my equation. And that will cancel out there. Now I've got area on the top, but it's multiplied by pressure. So I'm going to divide by pressure on both sides so that I end up cancelling those pressures and having area on its own. So my equation I'm using in the end is area equals force divided by pressure. Now I can put my numbers in. My force is 0.00513 newtons divided by my pressure, which is 3.90 pascals. That gets me an area of 0.00132 meters squared. So let's go ahead and enter that in our answer box here. 0.00132. Our unit was meters squared. Awesome. We found the area. Finally, the question asks, what is the surface area of the part of the knife that touches the butter? That's exactly what we just found. It's 0.00132 meters squared. In this question, we have a rectangular prism, which we can see in the diagram. We're told it has a weight of 14.5 newtons. It's placed on a thin sheet of ice that can withstand pressures of up to 3,030 pascals. We're asked to complete the chart by determining the force applied by, area of, and pressure applied by the rectangular prism onto the ice that it's on. Okay, so let's start out by filling in our knowns. In our table, we know that the force that the rectangular prism puts onto the thin sheet of ice is the weight force that it pushes down with. We're told in the question the weight is 14.5 newtons. So we can fill that in here. Next, our area. Now, we're not told the area in the question. However, we are given a diagram that shows the dimensions of our rectangular prism. And the area that's touching the ice is going to be the same size as this area of our rectangular prism here. So if we can find the area of that rectangle, we can find the area that touches the ice. So one of our sides is this one here, which is 0.063 meters. The other side of that rectangle is this one labeled here, which is 0.050 meters. So just to draw that out more clearly, if this is a bird's eye or top-down view of our rectangle, we know that one side is 0.063 meters, and then the shorter side is 0.050 meters. That area is the area of our rectangular prism that is touching that sheet of ice. That's the area we need to find. If we scroll down on our reference sheet, we get to the geometry section, which tells us the area of a rectangle. Area is length times width. So we're going to use that to figure out the area touching the ice. So area of our rectangle is length times width. We know that our length of our rectangle is 0.063 meters. Our width is 0.050 meters. So putting those in our equation, we get 0.063 multiplied by 0.050. Putting it in our calculator, we get an answer of 0.00315 meters squared for the area of our rectangle that is touching the sheet of ice. So we can go ahead and fill that in. 0.00315 meters squared. That's our area touching the sheet of ice. Awesome. So we have our force, we have our area, we need to find the pressure. Let's head to the reference sheet. And we're going to head back up to the part with our equations. And here, same as before, we're going to use our definition of pressure equation. Pressure equals force divided by area. Pressure equals force divided by area. We're looking to find the pressure, so this equation is already arranged correctly for us. We just need to put our numbers in. So our force is 14.5 newtons, that's the weight, divided by our surface area touching the ice, which we calculated was 0.00315 meters squared. If we put that into our calculator, we're going to get a pressure of 4,596 pascals. So let's go ahead and fill that in our answer box here. Awesome. So we've calculated our pressure. Finally, we're asked, will the rectangular prism break the ice? Now we're told in the question, the thin sheet of ice can withstand pressures of up to 3,030 pascals. So max pressure it can withstand is 3,030 pascals. Now we just calculated a pressure of 4,596 pascals, which is greater than 3,030 pascals. So based on that, we know our pressure is too high and it's going to break the ice. So will it break the ice? Yes, it will, because our pressure exerted is higher than the maximum the ice can withstand. So you can see in these questions, we're using our pressure, force, and area equation. For the force, often that's going to be the weight of our object. For the area, sometimes we'll be given the area. Sometimes we'll be calculating the area using the dimensions of our object. If you're calculating the area, make sure you're looking at the correct side of our rectangle. It's going to be the side that is touching the surface. We also might calculate the area based on an outline we've drawn of our object onto squared paper, and we can add up all the squares and figure out the area that way. but we're always going to be using the force, area, and pressure equation. Pressure equals force divided by area.